providing the certificate to only those who have attended the session. Okay, so stay tuned till the last. And after at the end of the while at the end we will be sharing one form here in this message section only. Just fill it up, and only those people will get the certificate. Okay. So for that, for supervised classification, first of all, we start with finding out some training sites. Yes, any issue? Yeah, anything anyone want to ask me? Yes, I've started the recording. Okay, actually, I started from now only, and the whole practical will be recorded, and we'll upload this video. Okay, it will take some time because we have to edit it a bit. Okay, so now I started. I explain about the unsupervised. Unsupervised means the task of software is more in unsupervised. We tell the software how many classes like uh, we need to assign. So software makes the classes, okay, and then we have to assign it. And unsupervised, we first of all make some samples. Okay, samples are actually called as signatures. Now, what are signatures? Signatures are called as representative pixels. Okay, now for example, suppose this is my image. Okay, this is my image. I will take some sample from each of the classes. Okay. Now, for that purpose, first of all, you have to read this image very carefully. Then you have to find the training sites. Now, for that purpose, you can change the band combinations to make it visibly more, interpretable. So, suppose I just took 5 bands over here, and I am making stacking like this. So here, this is the false color combination. So here I can see the dark red resembles features having more green cover. Okay, this is resembling a waterlogged area. This is the running water. So first of all, before collecting the samples, first of all, you have to get acquainted with this image. You have to read the image from every side. Okay, I have seen people, they just focus on certain parts. They collect signature from only certain parts, the part which they are quite aware of. So that will not make any sense. If you are using this whole tile, this is actually called as tile. You have to first of all get acquainted from each and every corner of this image, and then you have to find out the training sites. Training sites means wherever you think, like as I can see, this is a clustered settlement. This is a built up area. Okay, this is residential area, and I can see clustered of houses. So this could be a training site. I can collect some sample from here. Okay, for water, I can take a training site as this river as a training site, this waterlogged area as a training site. Okay, so the very first thing that you should do before starting image classification, you have to find out the training site, and then you have to collect the samples. Samples means we will collect, once you collect the samples, okay, and samples you have to collect at least 10 to 15 throughout the image. Now, once you collect the sample and merge them, they become signatures. They are then called as signatures. Now, what are signatures? So, suppose I collected the samples for water. Okay, now obviously I collected it from different part of this image. So this pixel value will also vary. Somewhere the water pixel may be 2, somewhere it may be the maximum, it may be 25. So in signature, the software will understand that the pixel values ranging from 2 to 25 resemble water. Okay, so this variation you will get more signatures, you will more samples you will collect, more variation it will make. Okay, then suppose for agriculture, similar thing I will do. I will collect the samples, and then based on the sample it will just have an idea that suppose 26 to 35 means agriculture. So in that way, we have to collect certain signatures. Okay. Once you collect the signatures, then you have to decide which classification algorithm you will take. So mostly these three techniques are used a lot: maximum likelihood classifier, random forest, and support vector machine. I have just quoted these three, though there are many. There are fuzzy logic. There is spectral angle mapper. There are many other techniques as well. Okay, but I have just categorized these three because these gives most of the accurate results. Okay, now how do this work? Let me start with the maximum likelihood classifier. So once you collect the signatures, okay, then if you like give a command to the software that the classifier you will adopt to group this pixel, suppose you are choosing for maximum likelihood. So in that case, what the software will do, it will reach to each of these pixels and then see what is the probability of each of the pixel to come to that particular class. Suppose it will first of all reach the first pixel and it will find that the pixel value of this is suppose 60. And here if we find that the suppose the pixel value built up is suppose 55 to 65. So it will automatically categorize this first pixel in built up. So this is what happens in maximum likelihood classification algorithm. Okay, and that's why it is used a lot actually. This technique is used a lot, maximum likelihood. The second is random forest, which I will explain even elaborately today. It is based on this machine learning technique and then support vector machine. In support vector machine, what happens? Behind actually, based on the signature value, the it actually works. It takes the classes in two axes. Suppose it takes the water in x-axis and suppose the agriculture in y-axis. Based on their signature value, what it will do, it will create. This is called as a marginal curve. Okay, it will make a this marginal curve, and the pixel value which are near to this. Okay, suppose these are the far. It will be that actual class. It will denote the nearer to it are will be categorized as mixed pixel. Okay. The third is random forest. In random forest, what happens? Random forest is basically a technique of machine learning. Now, what is machine learning? Machine learning is a part of AI, artificial intelligence. Okay, and in machine learning, what is basically what machine learning do? It try to imitate our human mind. So certain algorithms and certain, data are fit in the software in such a way that it will imitate what we think. Same like that. Okay. Now random forest, obviously here you can see two terms are there. And this forest, what we mean more, random forest. Okay. Forest means bunch of trees. Okay. In forest, what you will find? You will find bunch of trees. Okay. Now, what is the use of forest now in image classification? So, if you will ever visit a forest, you will find so many trees, and it will be so difficult for you to differentiate sometime. Okay, so in that way, what our human mind will do, or suppose let us take an example. We have visited a forest, and I saw so many trees. Some are tall, some are short, some have a big canopy. So I will differentiate so following certain parameters. Okay, if I will say that a tree is very tall and the leaves are conical in shape, so based on the parameter, I will assign that tree as a conical tree. Okay. So for that, what I did, I made some decision. The decision were based on certain parameters. The first parameter is the tree is very tall. The second is the leaves are conical in shape. Similarly, suppose I saw a jackfruit tree. So how my mind will decide that it is jackfruit? Jackfruit again, I will take certain parameters. Participant, can you just mute yourself? It is really very distracting. Someone has unmuted yourself. Okay, it actually distracts a lot when I'm speaking in a flow, so it distracts a lot. Anyway, fine. So in forest, obviously we decide, and for that we take certain decision parameters. And in random forest, this is called a decision tree. Okay. Now, obviously, I cannot decide something in using a single parameter. Okay, how will I differentiate between a suppose a mango tree and jackfruit tree? Okay, so I will have some parameters, and this parameter will flow in a tree shape. I will take one parameter that the trees are more. circular in jackfruit. Then it will have fruit which are quite elongated. It will have certain more things which my mind will automatically think about before deciding. Same thing is being done in image classification also. Okay. Now let me associate this with image classification. So as I said, in image, what we do, image classification, what we do, we try to group the pixel values, right? So in random forest also, we start with the pixel value, all the pixels. Okay, this is the first layer stack image that we take for process. Okay, and this is called as the root node. This particular, the pixels are called as the root node. Okay, now based on this pixel, we, as I said, we collect signatures. On now, let me take these three classes only. So we we took some signatures, right? Suppose I just took three signatures here. One is water. Okay, another is the agriculture. Okay, and another is suppose built up. Okay. Now, image classification, biggest problem that we face is of the mixed pixels. There are some pixels which is very hard to differentiate, like which class it will actually associate. Okay, suppose I am having a pixel, suppose agriculture here is between 25 to 23. So for water, I got the pixel value based on the sample that I collected between 2 to 25. For agriculture, suppose I got the pixel between 25 to suppose 25 to 35. Okay. And for built up, suppose I got the signature based as 55 to 65. Now, here, these are called as branches. So, like same like a tree, it will have a root node. It will have some branches. The branches will be associated, and these are called as the label data. Okay, if these branches will connect certain label data, and now it will further process, and here actually a process go that is called as bootstrap. Okay, bootstrapping means we just remove some redundant data. Okay, I'm not going to that extent today. I will just explain that as per the image classification. Okay, now here what will happen, this classes it will further decide the parameters, and all the pixel which will fall under this class will be assigned yes or it will be no. Okay, so now here we don't have any problem of mixed pixels. So finally we will categorize the pixel and we'll get the output. Okay, this is the final output, and this will be called as the leaf node. Okay, once we get the output. So here our problem is sorted. Okay, whatever these are the parameters that I assigned. So this parameter contains certain pixel value, based on that it categorized. Now here we will find some problem with this pixel because it is similar to this. Again it will make the further process based on iteration, and again it will have some yes and some as no. Now, obviously, some pixel will be there which the software will not be able to identify instantly. Suppose pixel number 25. So, it will again further run. It will now make certain more parameters, okay, to decide which pixel will actually have this. Though because we have already assigned rest of the 25 number pixel. So it will keep on programming. Behind it will keep on programming till it get the final leaf node. So in this, what you see, we certain trees are being created. These are called as the decision trees. And by compiling all of them, so this whole technique is called as a random forest. So in random forest, we take certain decision trees, and this decision trees means what? We have assigned certain parameters. Based on that, the software will function. Okay. But now, as you are in GIS field, and if you are working the software, don't have to do anything. Everything is inbuilt. Everything you will find in the software itself, and you won't believe the software will just take few minutes to complete this whole task. Okay, so this tool are easily available in QGIS. It is available in Saga GIS. It is available in ArcGIS. But this random forest is not there in ADAS till now. Okay, so you can easily use the QGIS software which we are going to do today. Okay, we are going to do this whole practical session also. Okay, so this is how actually the random forest work, and you can get a a very good result in random forest and in support vector machine as well. Okay, so these are the three classifier mostly used classifier, I would say, because in supervised you will find more algorithms are there. But these three, if you are ever thinking to do your research work or do want to do some kind of image classification, you can take these three options because these three will give you the best accurate result. And out of this, we found, because we have done a lot of work in these three, out of this, we have found that this SVM is giving us much better result. Though it may vary from person to person. If you have already worked in random forest, maybe you have got better accuracy. But we have seen the support vector machine is trending a lot and it is giving us a much better result. Now that is again based on the signatures that you are collecting. So as I said, if you want a very precise land cover to be created, you have to be very much well acquainted with your image. Once you get the image, you should first of all study the image very precisely and throughout the image. I have seen many students what they do, they just focus on the part which they are aware of. Don't do this mistake. And don't try to collect the signature just from a particular part. Try to collect it throughout the image, because more the samples you will give the softwares, more variation it will get. Okay. So as I said, now the third algorithm that is associated with supervised, this is also an amazing technique, but this can only be used for some well developed area. Okay. In object based, what happens, as I said, in supervised and unsupervised, we mostly associate with the pixel values. In object, we work both with pixel as well as the feature geometry. Okay, now this is much applicable in area having certain, proper planned area. Suppose there is an area where all the houses are planned systematically in a same pattern. Suppose all the houses are of same shape. So in object based, what you have to do, you just have to create the geometry correctly. So once you will give this input, this will be added as a signature. So what the all the houses having same geometry will be classified. So this is also an amazing technique. But yes, you cannot use this for an underdeveloped area, or you cannot use this for resource mapping because resources are not properly defined. Somewhere you may have different shape and sizes. But anyway, if you will ever go for, or if you will do some study on urban planning, and if you have a good resolution image, even this is also possible with Google Earth. We have done this object based classification using Google Earth image as well. Okay, by georeferencing and all, you can do this. So this will also give you very good result. It because it works based on both pixel as well as geometry too. Okay, so these are the three classification technique that we use to classify the images. Okay, now let us have some practical hands-on also, because it's already 7:30. So Saugata, are you there?
Yes, ma'am.
Okay, you are ready? I'm stopping
Yes.
the, okay, I'm stopping my uh, presentation and Saugata will present. Okay, he will be showing all the steps. So go through the steps very carefully and yes, Saugata, you can share your screen and go through the steps very carefully. And I will really appreciate if you will share your output with me. So I think all of you have our WhatsApp number. So you can share your output. You can WhatsApp us or you can mail us too. Okay, so I will really be appreciate your work. I will appreciate that this webinar will be bothful actually if you will do this work and share with us. Yeah. Yes,
Ma'am, is
Saugata.
it visible?
Yes, your screen is visible. You can now minimize your Chrome and open the QGIS.
Okay, ma'am. Thank you. So the plugin that we will be using for random forest classification is called Semi-Automatic Classification Plugin, or SCP. So you can just go to plugins, manage and install plugins, and if you type semi, you will see this plugin is there, Semi-Automatic Classification Plugin. So after you install this,
Phone is used as well.
you will see that a separate SCP menu will be available and a separate SCP toolbar will also be available. If you click on SCP and go to show plugin, two windows will appear. This one on the
Yes.
right hand side will be used for
Whether
taking the samples.
tomorrow.
Is somebody asking anything?
No, no, Swagata, you can carry on. Someone, I think, unmuted and I muted again. Okay, you
Okay.
can carry on. Participant, please don't unmute yourself in between.
Yeah, so this window you can dock on the right hand side because we will need this throughout the process. And this window will need for selecting some options. Uh, okay, so the first thing that we need is if you go to band processing and you'll see the random forest is available. It is written that ESA Snap software is required for running this algorithm. It is just a very small open source software. So if you go to Google and type ESL Snap, this is the official website. You can just scroll down and click on this main download of all toolboxes. So after you download and install, go to C drive and program files and search for Snap, the software name. There the binary folder bin, you have to go there, and this file's path you need GPT. You can just copy this path from here, go to QGIS.
Sir, your voice not clear.
Hello.
But I can hear
Your
him
voice
very
not clear,
clearly.
sir.
I can hear him very clearly. If you have any issue with the audio, please use a headphone because I can hear him very clearly. Someone also texted this on the message, no? But I can hear very clearly. So please use a headphone. Okay? Take a headphone instead because it's okay. We can hear. Anyone else have some issue with his audio? I think it's quite clear because I'm using a headphone, so I can clear very. The voice is very clear to me.
No
Understand?
problem, ma'am. We are
Huh.
all here
Yes, yes.
clearly.
So please, those who are having issue with the audio, please use a headphone instead. Okay? Yes, Saugata, carry on.
Okay.
Okay.
So now you go to settings and processing setting. There you will see the place where you have to paste the link, that path of the GPT file. So it will come up to this. At the end, you just type gpt.exe because that is the executable file that we need to run the algorithm. After this is done, you are ready to run the algorithm. So for this tool, the first we need to put the bands. So for today's example, we have taken the region of Delhi. I have downloaded from Lancet 8 the bands. We'll be taking the 7 bands. First, go to band set and click on this greenish button. You have to browse to the folder where you have kept the images. So we have, yeah, now we'll select the bands. 7 bands is selected, we open, and the bands will appear like this. Now, we don't need to do anything more here, you can just minimize, and you will see in the map canvas all the 7 bands have appeared. Now in this SCP toolbar, you will see there is an option for entering or selecting band combination, so band shuffling. You can just click on any option and automatically the band composite or layer stack will be created. You do not have to create it yourself. Once we have this, we will now taking the samples. For taking the samples on this right hand side window, you can go to training input, this tab, and you can see a blank space is there. Here is where all the samples will be added as a list. Now we have to understand one concept, two concepts over here, which is MC and C. MC is macro class and C is just class. Now, suppose we are going to create 5 LULC classes like water, built up agriculture, and so on. So those classes are referred to as MC or macro class, and the samples within each of those classes is known as just C class. So as we create one new class, we have to increase this MC ID manually. However, this CID, sample ID, is auto incrementing. We do not have to increase it manually, and overall it is unique. So if you have completed creating 5 samples in one class and you are going to a second class, you cannot start again from 1. It will start from 6. Now first we need to create the training input file. This option, create a training input file. This is a file that will be storing all the samples of the signature. Now we can go to this. I'll just name it training. This is a .sct file. Click on save. You see the file has appeared, the link. Now we will use some different band combinations for taking samples. Like again, in this place where you selected the band combination, you can enter your desired combination. I'll use a 764 for visualizing the built up. You see the violet regions are built up. Now, like in ARC, we have shapefile, and in ADAS, we have AOI, area of interest. Over here, we have ROI, region of interest. This is also a polygon. So, there is a polygon shape button over here. You can click, and you will see that you can now create and edit polygons over here. Suppose I am taking the first sample from here. Start by clicking by left clicking on the vertices, and on the last vertex right click and leave, and that is how the polygon will be completed. Now you have to fill in the details of this particular sample. The MC name is the class name, which is built up. ID is 1, and we can give a local name to the sample, which is B1, and this is also 1. Now you have to click on this reddish button, and it will be uploaded in a few seconds. Now, as you can see, each sample takes a bit of time, so we will be taking 6 samples for each class today. And a random forest, even with lesser number of samples, can give you a very good result. Although taking more samples will give you obviously better result. So we are done with one sample. We'll try to take from different areas of the image. B2. Now you see this CID is automatically increased to 2. And this is built up once, so we need to change and upload. B3.
So Agatha, take 5 samples for each, okay? Because
Okay.
we just have to show the steps, okay?
Okay.
So he will be taking 5 because it takes some time to upload, right? But you people take 10 whenever you will do, take at least 10 from around the image, okay? He is just explaining the steps. So just 5 will be enough because it takes some time to get uploaded.
B4. Let us take some roads. The last sample of build up. Okay, so we're done with build up. Now I'll use a combination of 564 for identifying water separately, which is extreme dark. Now we have to change the name from built up to water and increase the MCI and name this W1. But see, the CID has to be 6 because all the 5 have been already used. I upload. have some water. So we heat up to 3. W4. The last from water. Okay, now I'll use 542 for vegetation and agriculture. The darker red is darker green and red is vegetation, and the brighter red is agriculture. Let us take vegetation first. Again, we have to change the name to vegetation. Increase 3 view upload.
I think someone is presenting. Why so? Kareem Siddiqui, why are you presenting the screen when Saugata is doing? Saugata, can you just present again? Saugata, just present your screen again. Someone presented their screen and your screen is not visible now. Just stop your screen and share again. Saugata, can you hear me? Yeah.
Ah, yes,
Yes.
ma'am.
Yes.
Is
Yes.
it visible?
Participant, please don't try to click on your share button.
Yeah, so 2 samples are done.
And Rajiv sir, please share the feedback form and the this attendance form. Only those who will fill up the attendance form will get the certificates. Okay, so please don't mail or WhatsApp us regarding this. Please, and this is our feedback form. Please uh, fill this up and the attendance form as well.
Take some green areas as well. So done with vegetation, now start with agriculture. A1.
Rajiv sir, please share the attendance form again. The students are having some issue in adding that. Okay, so please be
Yes,
patient. We
yes,
are
we're not
standing.
able to stop that.
हाँ, ठीक.
We're not able to access that formula.
Yes, we are sharing. Okay, we have shared again. Please cross check.
Shogota sir,
Yes.
sometimes if we wrongly select the samples, how do we delete that sample? Kindly show that.
Yeah. Just a few seconds. After this is over, I Yeah, so suppose few of these are wrong, so you can click, press shift and keep clicking, and once they're selected, you can click on this red button, delete. It will be deleted,
Okay,
or
sir.
you can also select the entire class as well and click on this class will also get deleted.
Thank you, sir.
Oh,
We're not still able to access that form.
So please hold on. We are having some issue in linking that. So please hold on. We will share. Don't worry. Just have your concentration on this section now. We are working on it.
okay, so agriculture is now the last class for barren land, which is 765. The light lemon yellow kind of regions are barren land. Just a sample. Pakistan, barren land, Greece. It is named BR1.
Sir, what was the band combination for vegetation?
542. Yeah. the last sum. Okay, now we have to specify the colors corresponding to the class name. You just double click on the color and build up red, water, blue vegetation, dark green, agriculture yellow, finally orange for banana. Now in this window the work is done. To go to the other window. And yeah, you have to click on random forest. Now this is the final stage where the algorithm will run. Now everything else can be kept as default. This is the band set number, which is by default 1, and we're using the MC ID or the class built up water vegetation for classification. So you have to select this. And this can also be kept 5000 training samples pixel as default. But this one is important. This is the number of, as ma'am explained, the concept of decision trees. This is the number of decision trees that will be used to classify. Now, if you keep a less value like 10, 20, the result will be produced very fast, but it will not be very good. So, 100 is a very good number to keep. The higher the value, the more time it will take, but the result will be very nice. Now, this we do not need to worry about. We can click on run, and this is it is asking for the file name. So, LELULC. This is a 2023 recent image. So this is a P file will be saved. Click on save and it is going to run. So this will take about roughly 2 to 3 minutes. If your area is very large, it will take more time, maybe nearly an hour and a half. But this kind of small region, it is completed in few minutes.
So it will take some time to get completed, and we will be uploading this video in our YouTube channel. Okay, it won't be possible to mail each one of you. So we'll be uploading this on YouTube channel, and not only this, we have few more videos which you can use Okay, and we keep on uploading similar tutorials, video, and our webinar sessions on YouTube. So, yeah, limitation, I don't think so far we have any such. Okay, but yes, if you will do, yeah, our YouTube channel is Swastik EduStar. Just make a search by Swastik EduStar itself.
Ma'am, it is done.
It is done.
Hello, madam. One doubt.
Yes,
I have one doubt.
yes, please carry on.
Okay, let me start. How does the random forest algorithm handles the overfitting? So as we know that sometimes there will be overfitting of models. So how does this random forest handle this issue of overfitting of model?
So it has got its own inbuilt capability of doing that. Okay. So, but the major, drawback that working in QGIS, and if you will ever, even this random forest also available in ArcGIS. So the major problem that you can face is you cannot manipulate it afterwards. Okay, and rest, overfitting issue and all are inbuilt. So once you assign this 100 decision tree parameters, so it will automatically resolve those issues. Okay, but uh, like why have Sagat, I wanted to clip it. Okay, so those are inbuilt actually, right? So now let me take up some issues.
I have
Extraction,
another doubt.
yes. Hmm.
I have another doubt.
Yes, carry on.
So so what is the difference between the ANN and random forest? Is there any difference or are they
ANN,
same machine
ANN
learning
is
languages?
there is a difference. ANN is based on artificial neural network. Okay, that involves more part of deep learning, and random forest and SVM is machine learning technique. In ANN is even though we don't have till now we don't have any inbuilt technique classify technique to do image classification. GIS software, you can adopt ANN if you want to classify using ANN. So you have to use some Python interface in that case. Okay. So ANN, no doubt, is the best one because in ANN we just have to fit we even don't have to collect so much of signatures. But till now there are no such inbuilt tool for ANN right now. How do you manage data processing and
Mm,
so the report I was showing the picture during training? So look, if
uh,
once one of you asked about what the range of pixel that
I
we
have
have to,
another doubt. I have
can I
I
take
have
some
another
more?
doubt. Last doubt.
Okay, tell please.
So
Yes.
what is the difference between the multi-collinearity test and bootstrap? You were talking about bootstrap
Uh,
in
uh,
the
uh.
middle of, I mean, in the beginning of this session. So what
Bootstrap.
is the difference between the multi-collinearity?
Hello.
Go on, please.
Yes. So bootstrap
Yes,
basically
yes, ma'am.
while taking the decision when we face the issue of this mixed pixel. So to just interchange the parameters, what the software does in bootstrapping basically they replace some sample parameters. Okay, to basically avoid the redundant data. Okay, so in ANN basically this bootstrapping technique is used. And what the next you are talking about?
I was talking about the multi-collinearity test.
I'm so sorry that is not actually associated with random forest. Okay, so for that we can have some more session where we can only discuss about the programming part. Fine. So here this bootstrap technique is being used to basically replace the sample parameter so that we can have more variation and remove the redundant data. So anyway, just look at this image Saugata has just created and it is quite it is quite better. The result is quite better, and even he just took five signatures. So if he will do the same work, taking at least 10 signatures, so just imagine how accurate your work will be. Okay, so this is the whole technique of random. Yes, Swagata, you can stop your screen now. We have already 8:10 now.
Okay.
So Arc we cannot. Arc is a open source, sorry, commercial software, so it cannot be. Everyone cannot use it. Okay, so that's why we don't much emphasize. We mostly emphasize on the open source. Yeah. Rest, if you want more, like some of you talked about the ANN tool, so you can. We have some facilities now in Saga GIS. So those who are trying to learn these tools and techniques, please explore the Saga GIS also. In Saga, there are few more good technique classification algorithms available. Okay. So that's what we wanted to share with you all today. It's already 8:11. We have run some time above. And if you still have some queries, so please save our WhatsApp number. It's we will get the details in our website also. Swastik
Hello.
Advocate. Yes. Yeah, sorry, by mistake I clicked it. Yeah, by mistake I clicked it. Yeah. So if you still have some queries, so better you please WhatsApp us. We are already running. It's 8:12 over here. We have some more assignments now to do. So you can just save our number in contact. You will get the detail. If you want to know more about us, you can just save our number on WhatsApp. And if you have some more issues, then you can please WhatsApp us. Though I try my best to, though I have a very busy schedule, so I will try my best to sort out your issue in the weekends basically. So you can just save our number, okay? And if you want to know more about remote sensing in GIS, and if basically the students who are intending to make a career on GIS, so for them we have lot of courses. We have the diploma courses, and we are actually starting a batch on 9th of October. Okay, so if you want to learn more with us, learn to explore these tools and techniques more. And look, this GIS and remote sensing is updating. Daily you will find something new is being added to it. So we keep our best, we try our best, though I'm not basically from a programming field, but still we try our best to, explore these tools and techniques as much as possible. Okay. So if you want to learn more with us, then you can either visit us or you can text us on our WhatsApp. Okay, and I think we will be meeting soon with some more interesting topic. Okay, we try our best to bring some new techniques with you all. And this whole session has been recorded, and I will be uploading this video. It will take 2 or 3 days more to update and just edit the video and share, and you can get it in the YouTube itself. Okay. Fine. So still, if you have more doubts, please WhatsApp. Okay, you can get a WhatsApp number from our website. So WhatsApp us. We'll try to get back to you as soon as possible. Okay. So let's wind up here, and please fill up the feedback form. It really helps a lot. We let me be honest. We are also actually we are also startup. We try our best to share this knowledge, and we are also learning. Basically we are also learning. I still am a learner. I have a lot of things to learn, and this kind of webinar actually gives us the variety, that the kind of queries that we get from this webinar actually gives us the variety, like what we have to explore more. So thanks for being with us, thanks for spending your more than 1 hour with us, and it's really feels great to see people are getting interest in this field. And stay tuned with us, save our number, and whenever we will have the next webinar, you will get notified in the WhatsApp, Facebook, Instagram. Okay, so I'm signing off now, and Saugata, thanks a lot for detailing the concepts, and I think this will help the students a lot. Okay, take care.
Okay.